Hi, I'm John, a product manager at Snowplow, and I'll be talking about how to use AI to speed up your Snowplow tracking design. Good data is the foundation of many use cases across your business, from analytical to real-time operational and even agentic. And this all starts from having a solid tracking plan which defines which events will be sent at what point in the user journey. With Snowplow, you define data contracts in the form of event schemas, which describe the shape of the data that you're going to send. But designing and evolving these event schemas can be tricky, time-consuming, and hard to scale. So let's see how we can use AI to speed up the process. We'll be using our Snowplow CLI tool, which lets you define and manage event schemas via a GitHub repository, with each schema defined as a config file. And we've published this as an MCP server. MCP, or Model Context Protocol, is a standard that allows AI agents to use tools autonomously to solve a problem. We'll also use a couple of other MCP servers, notably a local file system, Git, and GitHub. So let's imagine we've been asked why users are dropping off in our mobile checkout funnel. To answer this question, we'll need to implement some tracking as the user goes from viewing their cart to selecting shipping and confirming payments. Let's send the screenshot to Claude along with a description of our problem and ask it to come up with a plan and a branch before committing to anything. So we'll hit enter here, and it'll go away and think about it a little bit. So here it is reading from the local file system to understand what we already have in place. And it's going to create a new branch so that we don't affect the current tracking implementation. It's going to check this out and come up with a plan. So a few things to note here. It is preferring to use our standard Snowplow events, for which we already have tracker plugins and data models defined for. This will make the implementation much easier. It's also adding entities to capture context alongside the raw events. And it's setting some triggers that will explain in which conditions these get tracked. So let's say go ahead. So Claude gets busy. It starts creating some local files. It creates a folder to hold all of these. And then it runs a validation command. And this basically checks if these schemas conform to valid JSON. And it's realized it needs to add some maximum values here and handle some optional properties. It runs an additional validate step here. And it's going to update the data product with this information. A data product is a collection of these schemas with some additional metadata around ownership and governance. So now it's validating the entire data product. And it's realized that there is a failure here. So it's set the wrong constraints, and it's actually going to search the web to find out what the allowable values are for one of these properties, and it's gone away and fixed this all on its own. Now it's going to commit these to the branch and create and raise a pull request remotely. So now it gives a summary of all of the things that it has changed, and it shows us the pull request ready to view. So let's open this up in GitHub, and we can see that it's run an additional validate step. Just to confirm, we can click into the individual files and see the line-by-line proposed changes. You could imagine this is, for example, a central data team who's reviewing all of these changes. And if we're happy with it, we can merge these in. Now we've also set up an additional GitHub action to publish these proposed changes to our Snowplow backend and pipeline. So this runs the publish command from the CLI, and you can see that this is working successfully. So now if we go to our Snowplow console, we can see the data product beforehand with no event specs, and if we refresh the page, we can now see that it's populated with these new changes. After this point, you can use SnowType, our tracking code generation tool, to automatically generate type-safe tracking code in the language of your choice. So this is a new paradigm for AI-assisted tracking design, using the Snowplow CLI's MCP server and GitHub Actions to quickly get a new use case live.